Float lock vise. More like float lift vise. Am I right? Look, these are the jokes, people. Hello, Internet. My name is Quinn, and this is Blondihacks. It's a big day on the float lock vise project because we are going to finish it. That's right, we've just got a few more clever parts to make for this thing, and we're going to put it to the test in the real world and see if this thing lives up to the hype. So let's go. The next piece I need to make is this little end plate here. It's kind of an interesting shape. So I've got this piece of flat bar here that I'm going to use to make it out of. This is a perfect case for layout, so I'm going to do this old school, at least partially old school. You've seen me set dividers and scribers thusly, but here's the old school way that people actually used to do it, and that's by using a scale. And the reason this works so well is because scales used to be engraved. And this is actually a much better way to do it. The problem is it's hard to find engraved scales these days. Most scales are printed now, and the engraving is important because you can feel the tip of the scriber lock into the marks on the scale. So that old school method is actually quite accurate, as long as the dimension you need is available on the scale. So if you want to do a lot of old school layout, try to find scales that are engraved. Look for older ones at yard sales and so on. The genuinely engraved ones are harder to find new these days. The only really critical dimension on this part is the distance between the two holes. So I'm marking one hole a little bit inboard of where it needs to be from the end of the part because I'm going to machine that end. I actually missed with the center punch there a little, but that's okay. It actually missed in a forgiving direction. And then I'll space the other hole away from that. I'm also going to extend both these lines across the part because I'm going to want to transfer these lines to the edge for a cross hole as well, as you'll see here. And then I'll center punch the other hole, and that one I actually did okay on. And then I'll mark both of the holes here. Now I'm going to be drilling these parts anyway, so all of this layout is really just kind of sanity checking essentially, and also it's just fun. I like doing layout like this. Then I do some larger circles for the outer edges of the part, and finally I connect the tangents of those circles. Now machining this part is going to be interesting. I'm essentially just going to machine to the lines because there's nothing too critical here aside from the sizes and spacing of the holes. I'll start by making the holes because they are the reference for everything else, and also the part is currently square and easy to hold. I've got an end stop there as well, which you'll see why in a moment. So after lining up that first hole, I center drill. And I'm actually going to cheat and use the DRO to get the spacing to the other hole exactly correct. But if I did my layout well, then the center drill here should land right on my punch mark, which actually it does, so it looks like my layout was accurate. But the spacing between these bores is quite critical because otherwise the sliding jaw may bind up during portions of its travel if the spacing of the two bars is not held the same all the way down the length of the float lock vise. And these are drilled out, a couple of pilot drill sizes, and the smaller hole is drilled out as essentially a bearing for the end of the lead screw, and then the larger hole is reamed to be a nice close sliding fit on the ground guide bar. Now the reason for that end stop is that it allows me to flip the part on edge, and using the same center point on the DRO that I did for that bore, I can cross drill for the roll pin that's going to retain the guide bar in this end of the part. Saved me some edge finding there. I only had to find the center line of the part. That's the straightforward stuff out of the way. Now, let's do the fun part. I'm going to bring in the rotary table with my corner rounding fixture that you saw me make in a recent video. I start by centering this up on the spindle with that little button there. Then I insert the dowel pin that's sized for the bore that I'm using as the reference. and the part slides down over top of that. There's a Morse taper down in the bottom of the rotary table there that's threaded. That's all part of this fixture. Go watch my video on making this fixture if you're interested. Then I clamp the other end with a Field Expedient tiny strap clamp. I can't clamp on that through hole there, it falls short of the T-slot. Then I use a square and another T-slot to square the stock up, and that gets the center line of the part aligned with the 0 on my rotary table. My plan was to machine all of that excess material off the left-hand side here first, which might have worked if I'd remembered to tighten the other end of the part down. But since it was loose again anyway, I actually took it over to the bandsaw and roughed it out close to my lines here. That'll save me a lot of machining. Now for the finishing cut, and this is the cool part. With the rotary table set to 4 degrees, which is the angle on the side of that part, I simply feed the y-axis down to the tangent of the circle, which I'm using as y equals 0, which is close enough for a shallow angle. Then unlock the rotary table and crank that around to the opposite tangent point on the other side of that arc at the end of the part. Because the angle is 4 degrees on both sides, I crank this around to 188 degrees. And note that the radius of this arc at the end of the part is being set by the x-axis position of the table, which is basic rotary table work. So here I'm just adding the y-axis travel to cut the sides of the part all in one setup. Lock the table once again, and then feed the y-axis back down to the other end of the part. Thus I've done both sides and one end radius of this part in a single machining motion, which makes a very nice finish all the way around the part, and everything's nice and accurate. Now, this is an overkill way to do this. You could obviously just file this, but I wanted to try out my little fixture here, and it worked really great, I have to say. I'm very pleased with that. Then for the other end, I just swap in a smaller fixture spindle there and clamp it down once again. Then for this end, I just have to lightly touch off at the tangent point of that arc and wind the rotary table around, and we're done. Then a little bit of deburring, and you can see the final part here. I'm pretty pleased with how that turned out. Once again, that was an excessively complex way to do that, but I wanted to try doing it that way. You could very easily just bandsaw and file that part to shape. What's cool now, though, is that we finally have enough parts to give this thing a little test run for the first time ever. With that end bracket in place and some temporary pins to hold everything together, I can actually see if the jaws move correctly. If they don't, I want to find out now and see if there might be some adjustments I need to make. But actually, this works extremely well. I ran the jaw all the way down to the far end just to make sure nothing bound up anywhere, make sure the spacing between the lead screw and the bar is correct, and everything worked really well. So I think this end bracket here is a success. So I finished that off by throwing it in the old cold blue. That'll match the jaws, and I think it'll look nice. The next part is really the brains of the float lock vise. It's the magic block that sits on the table and allows the vise to clamp and float as needed. For this, I've got this piece of 1/2-inch flat bar here. I'm going to rough cut some chunks out of it on the bandsaw here to make this block. The block is 2 pieces that clamp together around the round guide bar of the vise. It's possible that you could make this in one piece and split it after the fact, but the drawing suggests doing it this way, so this is what I did. To start with, both blocks get squared up and brought to dimension. I'm not going to cover this in detail. I've done lots of videos on squaring up stock. If you'd like to see one in particular, go check out my Mill Skills playlist. It covers this in detail, including why the steps are done in this order, why the copper wire is there, and so on. With both halves brought to this point, it's time to make the most interesting feature, which is this section here. The drawing says to put a 31 thou shim between the blocks in order to drill and ream this hole. Now I'm going to make that shim out of an offcut of that other bar stock that I showed. I started by squaring up 3 sides of the block as before, and then I'll finish it up from the remaining side. I'm showing this because it's an interesting technique for how to create extremely thin parts. The trick with making very thin parts on a milling machine is how to keep the parts supported. So what I'm showing here is one way to do that. I'm essentially making a C-channel. I mill down the center of the stock so that all the way down, the sides of the stock are always supported and the vise isn't going to crush it. And you can mill the stock down very, very thin doing this. Then once you're done, if you want to mill the edges off, if they have to be square, you can use a packing block like this. In my case, the edges don't matter, so I just zip them off on the bandsaw. The reason I went to the trouble of making that shim instead of using shim stock, like brass, something like that, is that I want all three of these pieces to be the same material. When you're drilling a hole that splits across multiple pieces, if they aren't all the exact same material, then the drill will wander off course into whatever the softest material is. So you saw me line up the blocks here with a parallel, and now I'm center drilling on the center line there, and I'm checking with some magnification. My center drill should be centered on the shim and equal parts into both blocks, and that looks good, so I will proceed to pilot drill. I'm also going up in relatively gentle stages here with each drill size. As you saw, my shim isn't quite as tall as the blocks are, so the bottom of the hole has a little bit of an interrupted cut in it where the shim ends, but the blocks are still going. I'm counting on the top 2/3 of the hole being enough support here for the drills. Now where things get interesting is the reamer. A spiral flute reamer would be ideal here. Anytime you have a feature longitudinal to the hole with a gap like this shim, or especially the gap at the bottom of my hole, you really want a spiral flute reamer because the flutes won't snag on those breaks in the material. Unfortunately, I don't have one in this size, so I had to take my chances with the straight flute reamer. Luckily, I did get away with this. The support at the top of the hole was enough to keep the flutes happy at the bottom of the hole. A quick check here with a gauge pin to make sure I've got a good fit. This needs to be a nice sliding fit on the diameter of the ground guide bar of the vise, and that feels really good. That should work. If that was not a good fit, I could, for example, go through one more time with an oversized reamer, but no need. All right, we're done with that, and now I can pull the remaining shards of the shim out of there. And of course, if it wasn't obvious why we did that, that's so that now the block is effectively a clamp with the correct radius on each half of the clamp. So it's got plenty of gap there between the two blocks for clamping forces. Then the two blocks get a cross hole the other way, which is just a clearance hole for the clamping handle. For this, I just used an end stop and the DRO to get the holes in the same place on each block. A little deburring, and these parts are basically done, although I can't test them yet. We need more parts before I can do that. So let's make those parts real quick. Back to this big chunk of flat bar, I'm going to make the corner clamp that goes on the drill press table. Once again, I'm doing this with layout. There's nothing precision or accurate required on this part. I marked out the border, and then I found the position of the center of the inner radius there. There's an inner radius and an outer radius on this L shape here. And then for the outer radius, I did not center punch that because I didn't want the center punch in the middle of the part. So for the outer radius, I just carefully held the divider on the center line there. And that is our part. I drilled out the inner radius there on the drill press, which is an easy way to start. Then I rough cut close to my lines all the way in and around the outside on the bandsaw. And I also chopped off the worst of the material for the external radius there, which will save me a whole lot of filing here in a minute. Then to clean up all those edges, I set it up in the mill, and I just milled down to my layout lines and also just kind of by eye to try to match up to the tangent on the curve there at each end of each surface. And I did okay with this. The matchup there isn't perfect, but we'll clean it up with some filing here in a minute. And the short side there was just short enough that I could actually just side mill it all in one setup, which was kind of handy. And I cleaned up the outsides as well, same way. And then the end gets drilled and tapped for mounting bolts for the top plate. And then of course the big beefy clamping bolt at the bottom. Very straightforward part, so I'm just cruising through this here. Not a whole lot to see here. And then I finished up by blending in my surfaces there where the milling wasn't quite perfect, and then some draw filing evened up the surface finishes there. The drawing also calls for a full end radius around that bolt hole there, but I actually thought that was going to leave too little material there. I didn't really like the idea of doing that, so I decided to just file some nice fillets instead. I was tempted to set up my corner rounding fixture again and do a full radius, but it's a really critical area there, so I want more material there. And then of course I just hand filed the large outer radius as well. And finally, a quick trip to the Scotch-Brite wheel hides all the crimes. and that part is looking pretty decent. It's not perfect, but for something that's going to spend its life living underneath the drill press table, it's certainly sufficient. The top plate that completes this clamp is a very straightforward part. However, I needed to cut it out of this rather large scrap of 3/16 plate. Luckily, the bandsaw had just enough throat to do that. I hacked a workable chunk off of it and then cleaned up the edges and once again just milled this down to size. And this gets a couple of holes drilled and countersunk in it. The wobbly woodworking countersink there actually works quite well in steel in a pinch. And that's all there is to this part. Those two parts both get a trip to the cold blue as well, and that is basically it for the C-clamp. Now we finally have enough parts to really give this thing a try. I've actually got the C-clamped to the table there because I couldn't find a bolt large enough. So the floating part of the float lock works, but the real test is the clamp. Does it clamp? Did you see that? Did you see what happened there? The clamp actually lifted off the table as I tightened it. That's the opposite of what it's supposed to do. The lock part of float lock is supposed to push it down hard against the table. With a feeler gauge here, I determined that it's being lifted 30 thousandths off the table when the clamp is tightened. Taking some measurements and doing the math on the drawings, it's easy to see how this happens. The distance to the center line of the guide bar on the jaws is less than on the clamping block plus the thickness of the plate. Now I've made everything two-dimension correctly here, so the drawing is actually incorrect in this way. The lower clamping block needs to be thinner. Now there's another feature here that is not in the drawings that Mr. Pete talks about in his making of this vise. He describes that the factory one originally had an angle as well on the bottom of that block to really create that locking effect. When he made his float lock vise, he didn't end up doing anything with that angle. I think he didn't have the original part, so he couldn't see what it was supposed to be. However, I read all the comments on all his videos, and one of his viewers actually did have an original one, and they measured the guide bar distance on both sides of the block and found that one end is actually 5 thou lower than the other. So I did the math on that, and that translates to a 1 degree angle on the bottom of this block. So I machined 20 thou off the bottom of this block and then added another 1 degree angle cut, which took another 16 thou off. Farther. 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 Too far. Boom. Like a boss. So now I have the angle and the block is slightly thinner than half the jaw width. So let's give it another test and see if we get the proper clamping action now. I'm just using a cap screw there because I don't have the final clamping handle made yet. So the floating action is good. So far so good. Let's clamp that down and see if it's tight. And oh boy, it sure is. I need to tighten my drill press table. Let's do a paper test here. With that clamp down, the paper is clamped tight. Excellent. So I think that worked. Let's go ahead and finish up this block now. I had an arrow marked on there because, of course, once the angle is on there, the orientation of the block is important. I replaced my Sharpie arrow with a stamped one made of a V and an L from my letter stamping kit. It's hard to see on camera, but trust me, there's a little arrow on there now. The last part then is the clamping handle. I've got a scrap of mild steel here from which I will make it. I'll start by facing off the end, as is tradition. Get a number 2 center drill in there and some tail support, and I'll start by turning this down. A couple of roughing passes and one nice finishing cut, and the stock is down to the largest diameter of the crank handle, which is the top part there. No real precision is required here. The guesstimators are just fine. I'll scribe off the area that I need to turn down further for the threads. Once again, no precision really required here. I'm just turning down to the line. The only dimension I really care about is the diameter of what will become the threads here. For a coarse thread in steel like this, I like to go 5 to 10 thou under the nominal diameter of the thread to make sure that the die is going to have a good chance of starting. I'll also bring in the chamfer tool here and put a generous chamfer on the end. Some people say this helps dies to start. I actually don't find that to be the case, but I like to put a chamfer on the bottom of a thread anyway. And in comes the die. For a coarse thread, I find it helps to put a lot of pressure forward on the die to start because you've only got one thread engaged on the die for quite a while, and if you don't have a fair bit of pressure there, then that first thread in the die will just chew up the end of the stock, especially if the stock is oversized at all, so cutting it under nominal helps a lot with that as well. But that is looking good. That's a decent thread. I want to put kind of as few threads on there as I can, so I'm going to do a test fit here with the clamping block. I want a couple of threads to be inside the block to make sure that there will be clamping action. I've only got about half a thread there, so I'm going to do a little more than that. I'd like to have as much shoulder there inside the block as I can, but I want to make sure there's sufficient threads there to guarantee a clamping action. Quick deburr on that, and now I can part it off. And Yahtzee. I might still get a couple of parts out of that, so I'll put that back in the bin, flip the part around, and I'm going to put a nice generous chamfer on the top there, just because it'll look nice, and actually it'll make it a little more comfortable to handle as well. And while I'm here, I might as well do a light facing cut on there and skim off any detritus from the parting tool. While I'm at the lathe, we're going to need a Tommy bar, so I've got a scrap of 316 ground stainless here, which should make a nice Tommy bar. This was part of a care package that was donated to me by a viewer a while back. A bunch of stainless came in, so it's nice to get a chance to use that. Just square it up and chamfer the ends of that slightly. Next I'll need some ferrules to hold the Tommy bar in place. I found this piece of scrap in the brass bin, so I'll turn this down to whatever feels like a reasonable diameter. Really no measuring required here. And I'll drill it out deep enough for 2 of these little ferrules, and then I'll ream it so that it's a nice close sliding fit on the Tommy bar, and those will just be Loctited in place. No need for threads or anything like this. If I ever need to remove this Tommy bar, a little bit of heat will break the Loctite, so that will work just fine. Next I'll put a generous chamfer on that so that they feel nice in the hand, and measure just by scale. Again, no real precision required here. Part that off part way, chamfer the back side of that, and then finish the parting. And do it all again for the second one. Final step is over to my cross drilling fixture on the mill to put the cross hole in for the Tommy bar. I've talked a lot about this fixture in the past, so I'm not going to go over again here how it works, but I center drilled, and reamed this hole for a nice close sliding fit on the Tommy bar. I want the Tommy bar to be able to move back and forth, but not be loose such that it will rattle when the drill press is running, which is super annoying. And that feels really good. It's an easy sliding fit, but it's not going to rattle around. I've got one ferrule on there, and then I'll put the other one on at final assembly. This was all just the most basic of lathe work, but I'm just really pleased with that part. Sometimes the simplest parts make me the happiest, and I'm really chuffed with how that came out. All right, I'm going to assemble it now with the clamping handle and make sure that everything still works. The floating part is good. Now let's see if it will lock. And yeah, once again, that seems really good. I'll do the paper test again here. Loose now, tighten the clamp. Now it's tight, and in fact, I can shred the paper if I pull hard enough. So that's a very good clamp, I would say. Well, here are all the pieces now finally made, and we're ready for final assembly. So here's what final assembly looks like. I'm now oiling everything as I go, and yes, I almost forgot to put the movable jaw on, and then the pieces get assembled with roll pins to hold everything together, and those roll pins could be knocked out again easily enough if I need to disassemble it. And there we go, there's the final product. Now let's give it a real test drive here with some drilling. The jaw action there is nice and smooth, so that's all good. And now let's go ahead and put a piece of flat bar in here. One of the features I love about this is those steps in the jaws, which makes it great for thin material here, which traditional drill presses are really awkward for. So I'll clamp that in there, and then I'll float it over to the drill, and then lock it down where I want the hole to go. This should be a good acid test for the downward clamping force of the float lock because it's a large drill, no pilot hole, and thin material. So the drill is likely to be really grabby here and the lifting forces will be high. So if it's going to lift, this is the time it should do it. And that worked great. I had no trouble there at all. Here's a really cool aspect of the design that I didn't appreciate until now. With just a quarter or a half turn of that crank, you can release the stock, put in a new part, or move the stock to a different location, and a quarter to a half turn of that crank locks it down again. So you don't have to move the float lock vise relative to the drill to swap out the part, which is really awesome. I was actually concerned that the crank was going to be constantly in the way hitting the drill press table, but for a simple stock change like that, it's not a problem. Overall, that thing is working great. I think it's really going to be a great tool. And of course, you can clamp it to other things as well. So you can clamp it on the workbench. You could make copies of the top plate of that C-clamp and place them in different areas around your shop and create a modular system if you like. Well, there it is. That's the float lock vise that I made from the publicly available drawings. This was a lot of fun to make. I think it's going to work really well in my shop. We'll see how it holds up long term, but early tests are encouraging that it's going to be a loyal companion on my drill press. So watch for this in future projects. Thank you very much for watching. Thanks to my patrons who make this possible, and I will see you next time.